Hybrid Cloud Show, Episode 9. I'm Aaron.
I'm Gary.
I'm Sean.
And I'm Shane.
Welcome to the show about public cloud, private cloud, and everything in between. Our views here are ours and not those of our employers. So I've been playing around in my home lab with LexD and trying to do something that I think, Sean, you mentioned back in one of our earlier episodes of trying to put infrastructure as code into practice in my home lab. And so it made me think that we should probably go back to what infrastructure as code is and how people can play with it. So to start with, what do we call infrastructure as code? Why is it that people keep recommending using it? What's the point of it all?
Well, I think a big part of it is that it pushes your infrastructure towards tools that you know. Everyone as a developer should know basic stuff like Git. People should know that they like version control, right? It kind of just makes everything familiar to a developer and easy to, start using these tools. And as I hope you figured out, these tools can be very powerful. And so less learning curve, version control, safety, depending on how you configure things, it's a good place to start.
So winding back a little bit further than that, what actually is it, though? We're talking about things here like Terraform, like Bicep, like CloudFormation templates, those sorts of things?
Yeah, all of the above. It's sort of describing a data center in text files. You're essentially describing everything that the typical data center builder would be doing. Wiring up networking, well, that's done with lines of code, and provisioning boxes, all done with code. So everything becomes this versioned, trackable set of resources that you can manage and understand and reason about and do all the, as Sean says, use a lot of the tools you're comfortable with. So you can do things like lintit. You can run unit tests against it if you want, if you get that far. So it's got a lot of power to it if you're willing to invest the time up front to get it right.
And aside from version control, I've seen advantages put out there like consistency, reliability, things like the ability to scale out a bit more effectively because you've declared what it is that you're trying to scale out. Are there any other sort of advantages you can think of off the top of your heads?
The big one for me is making it so that you don't start treating infrastructure like a pet. So if you can take a server or a piece of networking and destroy it and redeploy it exactly the same as it was before, you're much less likely to keep things around and start twiddling with them and changing things on the box and things like that.
Yeah, it's sort of the ultimate of Jim's suggestion that after you've finished writing down how you deployed something, you blow it up and deploy it again, right?
Yeah, absolutely. And a way I often see people get started with infrastructure as code is actually go and build out the infrastructure in the console first, understand what the building blocks are that you're putting together, destroy that, and then go and write it as code. And hopefully you get the same outcome.
Does someone want to help me explain the difference between declarative and imperative in the context of infrastructure as code?
So declarative infrastructure as code is effectively where you're describing the desired end state of the system. So you're saying that I want a VM with this operating system, with this much resource, and I need Nginx installed on it. And you trust that the infrastructure as code or whatever it is you're using goes away and provisions you exactly that. An imperative is basically saying, I need you to go and set up a VM. Then I need you to do an apt update and apt upgrade. And then I need you to do an apt install Nginx. And then I need you to go and pull these files from this Git repository for my Nginx config. So you're effectively defining the steps which you would take as an engineer manually to go and provision that piece of resource.
Okay, so it's more like bash scripting imperative.
Yeah, pretty much. Bash scripting would be one way of doing imperative IAC.
I like declarative a lot better because it makes all of my files idempotent as well, which means I can apply them multiple times. And because I'm only declaring the end state and the infrastructure as code figures out how to get there, it doesn't matter how many times I apply it, I'm always going to have the same result.
Yeah, in reality, I find that a lot of the IAC I write ends up being a little bit of a mixture of both, and then I'm having to worry about things like handling return codes and stuff, because I'm probably not going to go and write a Terraform provider or some kind of Ansible plugin to handle a specific piece of code. So I just kind of handle that manually as an imperative thing.
Yeah, I tend to write things where it's imperative wrapped around a declarative. So you might have a fairly static declarative file to define some piece of infrastructure, but the things around it might be imperative and be in order of things maybe to generate that file, we'll say.
And realistically, you're only going to end up with declarative infrastructure as code if you're using a tool that's designed for infrastructure as code, right? Instead of using bash scripting or whatever.
Yeah.
Precisely. So AWS CDK and Pulumi, I believe, is sort of like a programming language that lets you iterate and do all the common programming language things, but lets you provision resources in the cloud. Is that considered imperative or declarative?
Yes. I think it's probably a little bit of both. I think that the way something like CDK, the way I would look at it, is the undifferentiated stuff that I don't care about, it's going and doing for me, right? Like if I say I want this thing and I want it deployed as a Lambda function, I'm not writing the code to say, here's the specific set of calls you need to make to the AWS API to provision a Lambda function. It knows that stuff. But then the programmatic stuff I'm putting around that is probably a little bit more imperative. It's probably the way I'd look at it.
I thought it was interesting when I was going through this thing with my home lab because obviously it's a bit over-engineered to do it for a home lab, but I was playing with it anyway. And there were times that I thought I could see the advantage of something like Pulumi as opposed to the idea of Terraform or OpenTofu in my case for that use case. Just when you're starting to want to manipulate the data structures a little bit more before you then turn them into the infrastructure that you want. And I would be much more familiar doing something like that in Python than I would be in doing that in Terraform, where I think you can do a lot of that stuff if you structure it right and you do it all in the ways that are Terraform-y. But for me, it would be much more natural to do it in Python. It reminded me a little bit way back when of doing PHP and the difference between sort of inserting little snippets of code among my HTML versus having something that actually generated what I wanted.
I'm so sorry you had to write PHP. No, but Pulumi does a great job of removing those kinds of barriers because some people, they learn maybe Java first, and that's kind of how they conceptualize their code. And so they think about things as objects, right? And you can't really do that very well, and you have to learn a whole entire language if you're using Terraform or OpenTofu, whereas Pulumi just lets you write what you know, how you want it, and it figures out the rest. So props to them.
Do people have views on the differences between the more generic things like Terraform or OpenTofu versus the domain-specific ones, the sort of biceps or the CloudFormation templates or whatever for the particular cloud you're talking about?
I think one of the benefits I hear sold for a lot of the cloud native ones, which would be AWS CloudFormation or Microsoft Azure Bicep, is that cloud native means you'll get the most features just as soon as they're ready from the cloud provider. In practice, I haven't really seen much benefit to that. And sometimes the inverse, where some of the open source solutions are more innovative than the cloud native ones, and you find them going the other way where the cloud providers are taking from the open source community. So it's if you're going to try to evaluate whether to go for something generic versus cloud native, I've never seen a meaningful advantage on the cloud native side in terms of new functionality.
I think for me, if I'm going to learn a set of tooling and I want a single set of tooling that is going to work across any cloud I'm using, I'd probably lean to something a little bit more generic. So I guess if I'm deploying like a Kubernetes cluster, I understand what the bits I need to put together to deploy that Kubernetes cluster are. I understand the syntax of Terraform. Now, I'm not saying I'm going to be able to take a Terraform template and use that to deploy across all of the clouds, because clearly the resources I'm provisioning are going to be different. But the syntax and the way I'm writing it and things like coding standards are going to be the same across the three environments. I'm not having to learn a Bicep plus an Azure Resource Manager plus a CloudFormation plus something else. Right, I understand Terraform. I understand how that works. I understand how I'm handling things like secrets within Terraform, and I'm not having to do that 3 different ways for 3 different clouds, plus whatever I'm using on-prem, whether that's provisioning a VM and using cloud in it or something.
Yeah, there are some things where I'm sure it is much easier to plug in the cloud-specific technology. I think that you might need to use either ARM or Bicep if you're creating Azure Quick Start templates, for example. But if you are in a position where you can choose, then using something that you can use everywhere does seem like a reasonable starting point.
Well, having spent a couple of years working exclusively with ARM and then jumping ship to working exclusively with AWS, I can absolutely tell you that all of the knowledge I learned writing ARM templates and PowerShell desired state and all the rest of it is completely wasted now. Aaron is wincing at the thought of me spending 2 years doing it.
I'm trying not to cry. That's so sad.
One thing I will give Azure credit for is the fact that they know a lot of people don't like PowerShell and that they have separately got their AZ CLI that lets you do the same things in a more Linuxy way.
Last time I touched Azure, that was in beta, so I wasn't using it anywhere close to deploying stuff.
So what about Cloud Init in there?
So now we get to my favorite part, which is you have your infrastructure, you have your hardware. Now how do you configure the software running on that hardware? And there's a fine line between using something like Cloud Init, or even in Terraform, you can give it like a kickstart file or something to help get that started and then tell it to pull down this Ansible repo or whatever you want to do. What do you guys think about that? What's the correct way to kind of kickstart your VM or resource?
Again, I think that the answer is yes. So
I agree.
I've seen it done both ways. I've seen like a complete end-to-end, I hit enter and my entire thing gets deployed. So whether that's that I've got Terraform that deploys the infrastructure and then runs a load of Ansible against it, or whether I have a clear separation where I run a pipeline that deploys the infrastructure. I then have a bunch of unit tests that run against the infrastructure to make sure that's provisioned correctly. It has things like the right SSH keys, or it's joined my Open LDAP domain so I can log into it with my normal credentials or whatever. And then I have a separate pipeline that runs with a dependency on those unit checks to then go and set up OpenShift or go and install whatever application it is I'm running on those servers. I think for me, I prefer that degree of separation because I'm much more likely to run the same set of config management across multiple clouds or across multiple different environments than I am the infrastructure. And I think similarly, if I think back to when I was working for a software as a service company, our infrastructure, aside a couple of variables like host names or subnet IP ranges, would be exactly the same across all of our customers. But maybe the set of applications we were deploying or something like that would be separate. So my preference has always been to keep those distinct. That also means that if I want to swap out whatever config management platform I'm using, I can do that much more easily. It means that I can take patching and things as a separate set of process or a separate set of config management to deploying the underlying infrastructure. And the bottom line is that once the infrastructure is deployed, very seldom do I want to touch it or reprovision it, or there are certainly underlying components of it that I wouldn't want to touch. So for me, keep them separate, handle the racking and stacking of servers, so to speak, and then the setting up of the servers as something separate.
You certainly get some advantages in using the right tool for the right job. I noticed that Cloud Init, I believe, has a single line that will update the packages on an Ubuntu system rather than you having to, do the apt commands that go through and do it. So you get, you can get more ergonomic code by using the right tool in the right place.
Yeah, and I think it's like Sean said, it's where do you draw the line between those things? Because for me, I've always done like a update base packages on the system as part of deploying the infrastructure. So I would pop a Cloud Init file into the Terraform where I go and deploy all the servers and install the package updates on them. Equally, I've seen other people put that as like step 0 in their Ansible as they run that, because it might be that one team provision the infrastructure and then there's a couple of days before that gets handed off to an application developer to go and deploy whatever's getting deployed on top of it. So it's, I guess, 6 of one and half a dozen of the other as to where you put things like that. But it just depends, I guess, on what the team structure is, who's doing what. There's a whole bunch of questions there. I've seen it done both ways.
And then do those tools change if you're talking about VMs versus Kubernetes, for example?
Well, I guess it depends if you're administrating a cloud versus using a cloud. What do you think if you're administrating a cloud? You don't have to do any of that, actually. You don't have to set up SSH keys. You don't have to do Cloud Init or anything like that.
Yeah, if I'm using EKS or AKS or something, I'm probably just going to use whatever managed nodes the cloud provider gives me, just so that I don't have to worry about those things. So again, the answer is probably it depends, right?
And what about structuring your code in an infrastructure as code thing? I originally sat down to do my home infrastructure and put everything in one big sort of Terraform OpenTofu project where it was my home infrastructure, and then rapidly started breaking that all out into different pieces. What are your tips around modularizing your infrastructure as code?
I think there's a bit of a theme, which is it depends. infrastructure as code is code. So you're kind of nearly asking, like, how do I structure code? And depending on the problem you're solving, it really does depend. What you described, though, in your home lab sounds perfectly fine. Like, knock out a Terraform file. It's simple. It's straightforward. It's not premature optimization. Yeah, you start to feel the pain. You start to split things up in the modules. You can go down a completely abstracted rabbit hole of, like, you have code that's completely vendor agnostic. So you might write a load of code that doesn't know what technologies it's using behind it, but is vending very abstracted concepts that engineers need to use, but don't need to care about the underlying hardware or infrastructure behind it. So yeah, for me, it depends, but maybe others will disagree.
No, it's what you said. It's whatever makes the most sense for the point, for what you're doing right now. So, for example, one time I did this, I was on a team that was very advanced in AWS. And so we structured our things by environment and then by basically resource type. So like networking, NACL, security groups, that was one file, right? And then EC2 instances was another file. And that made a lot of sense. But on another team, my devs were much more application focused. And so that's how I structured it for them. I said, here's a folder for each application and all the resources for each application go inside this one file. And that was it.
It seems that nearly all of them have got some kind of concept where you can create a module and then pass it parameters so that you can keep your logic a little bit separate from the configuration parts of your logic.
Yeah, I always tend to break out things that I know are going to change between deployments. So I kind of said earlier, things like IP space or prefixes for host names or version of Kubernetes I'm deploying or what AMI or base image I'm deploying a VM from. Those are things that I'm likely to frequently change and are likely to change between environments. So I put those in some kind of parameter store and they get pulled at build time for when I'm running the infrastructure as code. Then there's also, I tend to do like some yes-no flags for certain things. So there are some teams I've worked on where we log into an AWS account and the underlying networking and security groups and transit gateway and things that link to the rest of the network have been deployed for us, as those are more like platform engineering type environments where we just get vended an account that has all of the kind of company security policies in. So I want an option to go and turn that stuff off. I just want to go and deploy the VMs on top of a VPC that already exists. So again, it depends, right? It's sort of the answer for all of this stuff as to what gets deployed for you and what are the things that you know you're going to frequently change and how do you break that stuff out?
One of the things I've found hugely valuable or I've appreciated doing in the past was minimizing the amount of change in the, we'll say, declarative IAC between environments. So what I mean by that is the same file that'll be deployed to an engineer's local development environment versus their staging development environment versus production stays the exact same, with configuration being the thing that changes between them, because what you'll have is this works in my dev environment, but it's screwed up in production. So keep the changes as small as possible between environments if you can. So that's a sales point for sticking more on the declarative side and using parameters to have a very siloed, isolated thing you're going to deploy.
Yeah, I'd stick something like machine name prefix or VPC ID in a parameter store in a Jenkins file or something like that. And then that just changes between pipelines. So the actual infrastructure I'm deploying remains pretty much identical. I just change those flags and I might change machine type or something from a C5 X large to a T2 small or something like that so that it's not costing me as much. But beyond that, I want all of the software stack and all of the network stack that gets deployed to pretty much be the same between dev, test, pre-prod, prod, UAT, or whatever.
Yeah, the main place I've used infrastructure as code historically has been around the CI/CD sort of pipelines for testing applications and so forth. And so there it obviously has to be complete in the test or it was just going to fail on you. And then it was interesting coming to it from the other end of the spectrum where these are things that are designed primarily for home use. And so I came into weird quirks like my Pi-hole that lets you back up from the command line, but apparently doesn't let you restore from the command line. And so, you have these weird workarounds you need for some of these particular applications that I hadn't expected or come across before.
Yeah, there's loads of weird stuff that I do at home that I'd never want to do in a business environment. Like, for example, working around getting Pi-hole in a container working on Ubuntu when you've got the weird DNS stuff that Ubuntu does that's different from every other Linux distro. And I'm sure there's good reasons for that, and I'm sure there are ways of working around that. But at home, I just kick off a shell script from the Ansible that runs the command that I know works and then returns in a reasonable way. And then I deploy the container after that. So there's a bunch of stuff that you probably don't need to worry about for just getting started that you probably want to handle a little bit more gracefully and in a bit more of a declarative way in a real production environment, I suppose.
It did show me, though, some of the advantages, which effectively the sort of thing you were talking about, Gary, where in LXC, for example, LXD, you have particular configurations if you want to run Docker containers inside a LXC container. And that's a set of commands that are in each of my different documentation pieces for each of my different Docker on LXC sort of setups. And that's just something that can become reusable code. And that can be something that I pass my Docker container and it launches in the way that I expect. So some of that stuff I thought was neat, and how you could take something that is structured out and then add in different hardening steps or whatever that you want to do on all of them and see if it still works as you expect.
I mean, for me in my home lab, I sort it by sort of server type, and I've got 3 different types of servers, if you like. There's an edge transit server, which does like Nginx reverse proxy and WireGuard and things like that. Then I've got an application server where I know that I'm going to need Nginx for internal reverse proxy and Docker. And then I've got a few other types of machine that do a specific thing. And I know that if I log on to App Server 5, it's going to be exactly the same as App Server 3, which is really, really handy, because if I'd hand crank those, then I would have no idea what differed between the machines. Equally, it's really great between like distribution upgrades. So I know that when I upgrade all of my infrastructure to 2404, I probably just have to change like the distribution version flag from Jammy to whatever the name for 2404 is, and everything kind of handles itself. So that's pretty nice.
Infrastructure as code is usually thought of as like Terraform, Pulumi, right? The hardware kind of aspect of it. What do you guys feel about other tools like Puppet, Chef, Ansible that are meant for this kind of second stage operation to actually configure your services? Is that infrastructure as code?
It's a fine line. I've always defined it as configuration as code or configuration management of some description, but that's maybe just the old school sysadmin in me, because I kind of like to think that I've gone and I've racked the server and that's my infrastructure as code. And then I'm going and installing the operating system on it and connecting to the iDRAC and installing Ubuntu or CentOS or whatever. And that's then my config as code.
Yeah, it's sort of interesting. Like if you think about Ansible from like a containers mindset, where the container Docker file is essentially the thing configuring the operating system. I consider Ansible, as Gary says, like configuration, but for some reason, Docker files are sort of more like infrastructure. I think maybe it's because of the stage of things. You build your image first and then you deploy the infrastructure. Whereas with servers, it's you spin up a server and then you apply the Ansible afterwards, or whatever configuration manager you're going to use. But you're right, Gary, it probably is just the old school way of looking at things.
I think that line also probably moves depending on if I'm using some kind of managed cloud native service rather than provisioning a VM and running it myself. So the stage at which I hand off to, now I've got my config management and I'm spinning up some containers, is probably in a slightly different place if I'm using EKS versus spinning up my own Kubernetes cluster or something.
And how do you deal with configuration drift?
I do not ever log into the server, which might be an unpopular opinion, but I just make sure that logs are being pumped off somewhere external. Anything that I need to troubleshoot, I go and work out exactly what's happening from log files or metrics, and then I go and fix that in code. So for me, actually, all of my servers have a randomly generated password that I do save off somewhere, but I try not to use if I can. They do not have SSH enabled, and I've got no way of getting onto them other than if I go to the console and type out the randomly generated password. And for me, that forces me to make sure that any change I make is done via the code, which is probably quite an extreme way of doing it. But it's just meant that I know exactly what is on my server, because if it's not in Git and it's not run through my Git pipeline, it is not there.
I think that's an admirable position to hold in a professional environment. On my home lab, though, maybe I should do the same thing, but on my home lab, oh God, I don't know how to fix this. I'll just edit this text file and see if this fixes it. And then it's all worthless. All the IAC is now worthless. Whatever I just did is never captured, so the rest of it's worthless too. But fair play. That's probably something I should adopt as well, just to keep me in good habits.
I think for me, it's because my home lab crosses over so much into home prod that I've been burned so many times by going, oh, I've changed where this application lives. I'll just SSH into my box that's running reverse proxy and update the host name of where that lives. And then my IAC runs automatically like 4 days later or whatever to keep the box in sync with whatever config it is. And it gets overwritten. And I get the call at 11 o'clock at night when I'm in a hotel from my wife saying, oh, I've put the kids to bed and I want to watch a film and now I can't get to Jellyfin. Oh, crap. Yeah. So I've just forced myself to make config management and Ansible in particular, in my case, the single source of truth.
You guys are both right. If you guys start with infrastructure as code, you must stick with it. There is no escape hatch. There is no easy way to detect configuration drift besides sticking with your principles. So just final note to all of our listeners, if you start this journey, we're right there with you, but you gotta stick with it.
Well, we better get out of here then. Before we go, just a quick plug to say thank you to our existing PayPal supporters and patrons. If you want to join those people, you can at hybridcloudshow.com/support. Where on Patreon, for various amounts, you can get an ad-free feed of either just this show or all the Late Night Linux family shows, and sometimes you get episodes early. We are still trying to build our audience, so please do keep sharing it around. We appreciate it, and we appreciate all of your questions and feedback. If you want to send any in, please do at show@hybridcloudshow.com. We'll be back in 2 weeks. Until then, I've been Aaron.
I've been Gary.
I've been Sean.
And I've been Shane.
See you later.